Good morning. This recording is for Pre-Algebra Chapter 4, Lesson 7. No quote today because some of you will have to watch a second video after this one. All right, moving on. Simplifying expression by doing as many of the indicated operations as possible. The invisible one exponent. If no exponent is there, then the invisible one is there, which is going to be coming in handy, especially when you have to add exponents and multiply exponents. So, if we have a to the fifth times a times b to the second, we are really going to end up with a to the fifth times a to the first times b to the second. Well, we can add exponents that have the same base. I'm going to skip ahead and show you that real quick. There you go. Same base. Add exponents if they have the same base. But we'll talk a little bit more about that in just a second of why you can do that. So there we go. So now that they've got the same base, we can add them. So a to the fifth plus 1 is a to the sixth, which times b to the second is a to the second, b to the a to the sixth, b to the second. So second, we have 0.2 to the second times 0.2 to the third. Since the bases are the same, the big numbers are exactly the same, we can add the little numbers. So it's going to be 0.2 to the second plus 3, which is going to then be 0.2 to the fifth. And then when you actually know the number, I will expect you to do the math. And for you guys with scientific calculators, I can show you how to do the exponent. With those without scientific calculators, you're just going to have to do 0.2 times 0.2 times 0.2 times 0.2 times 0.2. Which can get a little repetitive, but if you have a scientific calculator, I can show you how to use it. So if you do use your scientific calculator, you're going to get 0.00032. And again, you can only add the exponents of bases that are the same. If I had, let's say, x to the second times b to the third, I can't add the 2 and the 3 because the x is different from the b. Okay? So again, base, big number, exponent, little number, the whole thing's called the power, and adding exponents only works if the bases are the same. Don't add bases that aren't the same. All right, next slide. All right, using the commutative property, moving things around so that variables and numbers that can be multiplied together are next to each other. So we need to get all the numbers together and all the letters together and all the letters that are the same together. So I've got negative 2x squared times 3x to the fifth. So I'm going to get all the negative 2 and the 3 together, and I'm going to get the x's together. So then I can multiply. What's negative 2 times 3? Well, negative 2 times 3 is negative 6. And x to the second times x to the fifth is really x to the 2 plus 5, which is 7. So we have negative 6x to the seventh. All right, next one up. We have 5a to the third times 3a. And remember, if that a doesn't have an exponent, it actually has an invisible 1. There it is. And this is actually what we call expanded form, by the way. I write it out in expanded just to remind you that everything's being multiplied. And you could actually write it out even more by saying 6 times a times a times a times 3 times a. And that might even make it even easier for you because then you don't even have to add the exponents. You can just say, well, I have 3a's here and they're being multiplied, and 1a here that's being multiplied. So it's 4a's being multiplied, which means it's a to the fourth. So then we have the 6 and the 3 next to each other, which is 18. 18a to the fourth. There we go. All right, last up for this section, because again, some of you are going to have to watch 2 presentations today, 2 movies. Some of you will not. All right, so finding a power of a power. So a power of a power is when you have 2 exponents going on in there. 1, 2, right? So when you have 2 to the fourth to the second. So a power to a power, or a power of a power. This, I'll write it out in expanded form in just a second. But when you have a power to a power, you're going to multiply the exponents. So it's going to be 2 to the fourth times 2. Which is 2 to the 8th. Now, if you were to write this out in expanded form, it's basically 2 to the 4th times 2 to the 4th, because you have it 2. If it was a 3, if that was a 3, which you can't see now because I totally blocked it out, then you have 2 to the 4th times 2 to the 4th times 2 to the 4th. So the outside exponent tells you how many times you're doing the innermost exponent times itself, which is crazy, but get used to it. So if I were to write 2 to the 4th, it would be 4 2s. And if I were to write the other 2 to the 4th, it would be another set of 4 2s. Now, how many 2s do I have? Well, I have 8, right? I have 8. So there you go. So it's 2 to 8. So I'm just writing the same problem, but in standard form. So let me give you one more or two more examples. One more example, I think, and two more examples. Two more examples. So if I were to write this in expanded form, it would be something using a actual tool. It would be c to the 4th times 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 c to the 4th. Because remember, the exponent tells you how many times to multiply the base. So in this case, the base is c to the 4th. But the innermost base is actually c. So I have 4 c's there, 4 c's there, 4 c's there, 4 c's there, 4 c's there. So that's really, okay, let's see here. It's really c to the 4th, right? Yeah, okay. Yeah, and of course, because I've written over my own notes, c to the 20th, because 4 times 5 is 20. So again, multiplying here would also be easier than writing it out in expanded form. So just multiply the exponents, all right, when you got a power of a power. Next example, we have 3 times m to the 3rd to the 2nd. So we're going to multiply the exponents. 3 times 2 is 6, and then it's 3m to the 6th. All right, I'm done. Go watch the next video if you're one class. Don't go watch the next video if you're not the next other class. All right, bye.